x. What is the meaning of that? The second derivative. First derivative is 3 cos x. Once more, it's what? It's minus 9. What? Sine 3x. That is d squared on the x. Then 5t, derivative of sine 3x is 3 cos 3x times 5 is what? It's 15 what? Cos 3x. And this is the answer. Okay, that is theorem 2. Again, we look at theorem 2. Should be a piece of cake, but very important theorems. 1 over d squared minus 1. The action is x squared plus 1 bracket there times a to the power x. Again, theorem 2. There is x squared plus 1, which is my f at x. There is the exponential. So you can't use theorem 1 here, theorem 2. Theorem 2 in front. Then fd, 1 all over. Where there is d, we put what?
Is
we
d
put
plus 1 all squared.
Yes, d plus 1, yes, all squared. Minus 1 into f at x. My f at x is what? Is x squared plus 1. Work it out. That is a to the power x. 1 all over what? D squared plus what? Plus 2d plus 1 minus 1. I'll get that on what? On x squared plus 1. Next, we remember I've seen something like that before. It's a to the power x. 1 over d is common. Then you're left with 2 plus d on what? On x squared plus 1. 1 over d is known. It's a to the power x. 1 over d is known. And we have here 1 over 2 plus d. That is 1 over 2. Common factor, 1 plus d. Remember the expansion that we know by heart now. X squared plus 1. That becomes a to the power x. 1 over 2d. d and 2 is 2d. Expansion, it's 1 plus d to the power minus that on what? On x squared plus 1. I hope we are together there. It's a to the power x, 1 over 2d. We know terms coming out of that. 1 plus d to the power minus 1. First one is 1. They all alternate. And I must stop at d squared. I hope you know by now why stopping there, because that is 2. On what? On x squared plus 1. This is very interesting, good people. Once you know it, it gets into your nerves. So it's a to the power x, 1 over 2d, into 1 times the whole lot. The whole lot is that. So it's x squared plus 1. Then d on that, derivative of x squared, it's 2x. So I've got minus 2x because this d is negative. Derivative of 1 will be 0 in any way. Then twice derivative of that is 2x, and then becomes what? Plus 2. Okay, plus 2. 2x and 2. Then that gives us. That becomes a to the power x, 1 over 2 into. The 1 over d means integrate. What is the integral of x squared? Is x cubed over 3. What is the integral of minus 2x? It's minus x squared. What is the integral here? I'll get 1 plus 2. It's 1. What is the integral of 1? Is what? It's x. And this is your answer. Finish. That is theorem 2. And we have seen that before. Okay. Let's look at the very last one. Theorem 2. One, 4. It's 1 all over d squared plus 4d plus 4 acting on what? On 16x cubed a to the power 2x. Without any shadow of doubt, theorem 2. Mangabas. Theorem 2. Theorem 2, exponent in front, a to the power 2x, 1 all over. All over what? All over d. D, it's d plus 2 all squared plus 4, there comes in d, is d plus 2 plus what? Plus 4. What is f at x? My f at x is 16x cubed. This one is a little bit long. It's a to the power 2x times 1 all over. That will be d squared plus 4d plus 4 plus 4d plus 8 plus 4 acting on 16x cubed. Are we still together? That gives us a to the power 2x.
Yes.
1 all over d squared. 4d, that will be 8d. 4, I think that's 16, acting on 16x cubed. Right? We must work this thing out. If I remember very well.
That's all squared.
Yes, it's 1 over factors I are d plus 4 all squared. D
plus 4 all
plus
squared.
4 all squared, acting 16x cubed. Now, it's a case whereby we know that we don't know that one precisely. In other words, we need to expand that. If it was 1 here, it was going to be okay, but it's 2. It's not easy to spot up the terms. So we expand that using binomial expansion. So we expand that, perhaps aside, expand what? That will be 4 plus d to the power minus 2. So when we expand that, according to binomial expansion, is what? It's 4 to the power minus 2.
To the power minus 2.
Minus 2 and minus 2, then a4. Ngiyabothi mina ngiyakhela kule eyandule eyasekuqaleni. Minus what? Minus 2, minus 1, all over 1 factorial. Plus the next one, minus 2, minus 2, minus 1. Angithi? 4 to the power minus 2, minus 2. There comes in d over what? Over 2 factorial plus the third one. Sorry, squared here. The third one, I'll stop at d.
Sorry, sir.
Yeah.
Ukhohle udila kule sibili.
Yeah, ngiyabonga. Thank you. Right. Then the third one is built from the previous Ambuga. Minus 2, minus 1. Bring the top one. Minus 2. Then what? 4 to the power minus 2, minus 3. Then what? D cubed. All over what? All over 3 factorial. If you work this thing out, this is 1 over 16. That thing there. Here is going to be, this is minus 2. This is 4 to the power minus 3. 4 cubed is what? 64. So that is minus 2d over what? Over 64. Let's work this thing out again. Minus 2. This is minus 3. That whole thing here, it's 6. 6 over 2, that's 3. That is plus 3. This is 4 to the power 4. 4 to the power 4, 64 by 4. That is 1056. Yeah? It's 256. What is 64 by 4? I don't have a calculator there. But d squared, what is 64 by 4? It's 256.
Yes.
256. Then the next one will be, I think it's minus. This is 6. This is 6. 3 factorial is 6. That whole thing cancelling. Salenalo minus 4. So it's minus 4 d cubed all over. What is 256 times 4? I think it's 1024. Check for me there. In other words, it's 4 to the power 5. Yes, right. So in other words, the terms that comes out from here gives us that. Whether they are simplified, or let us try and simplify that. Perhaps we can simplify it. So it's 1 over 16, 2 over 64, that's 32, 1 over 32 there. 3 over 256, just divide there. 325, that's 24. You just leave it like that. So that's 3d squared over what? Over 256. But the other one, if you were to divide by 4 or by 2, it's 2d cubed over what? Over 512. Right. I think we can also divide 2 over 54 over 502. 2 there, it's 1. Blah, blah, blah. We can get the correct answer. Therefore, we go back. Therefore,
acting in 16x cubed.
It's Ubani ma? Ubani?
It's acting in 16x cubed. 16x cubed.
Okay, so it's e to the power 2x times 1 over 16 minus d over 32 plus 3d squared over 256 minus 2d cubed over what? Over 512. That is the expansion. Yes, 16.
What if you simplify that 2 over 512?
Yes, got a issue log in log, but you can simplify it, whatever, it doesn't matter. You get the same answer. That gives us a to the power 2x into 1 over 16 times 16, that becomes x cubed. Derivative of x cubed. Mind you, there's 16. X cubed is 3x squared. 3 times 16, it's 48. So that is minus 48x squared over what? Over 32. You'll simplify that. Plus second derivative. Mind you, we got 48x squared. 48x squared. Once more, it's going to be 96. So it's going to be 3 times 96 d, sorry, not d, 96 what? X, because it is the second derivative of that, over what? Over 256. Last one is the third derivative. Derivative of 96x is just 96. So it's going to be minus 2 times 96 over 2 over 512. And your answer that you are supposed to get here will be equals to what? X cubed minus what? 3 over 2 x squared plus what? 9 over 8 of x, and lastly minus 3 over 8 when you simplify that part there. That is all what Theorem 2 says. Theorem 2, d is replaced by d plus a or minus a. Let's move on to Theorem 3. Theorem 3, very important theorem, good people. Theorem 3. F d squared on either sine ax or cos ax, we are going to get f at minus a squared function is sine ax or cos ax. Theorem 2, Theorem 3 talks about the derivative of a sine or a cosine function. It simply tells us that when you differentiate sine function or cos function twice, d squared means twice. If you differentiate it twice, yes. Yes.
So Tisha bengicela uphindele theorem 1 sanda kufika manje I think ushayibona. Ngiyacela.
Theorem, I am miles away, my friend. Perhaps I'll repeat it just before I finish the lecture, okay? It was going to be better if it is Theorem 2. Theorem 3, I mean, 2. So I'll finish it right at the end of the, or before the end of the lecture. Okay? Fortunately, Theorem 3 is not related to Theorem 1. So, Theorem 3 simply says, yes.
Sorry, sir. Le theorem le oyisho manje le alesithathu, if like for instance like sebenginikeze o-cot no-tan futhi I apply kubona kufanele ngibashintshe ngibayithi in terms of sign.
Yabo lento engikunikeza yona nje iyonto engiyibuza, engakunezile yona ngeke ngikubuze leyo. Okay, o-tan no-cot no bani, nothing has been said about those. Okay, good question though. Okay. The function I'm dealing with here is sine or cos, full stop. Okay. Right. It simply says if you take twice the derivative of sine or cos, it means, do you see this minus a there? This minus a is that a there. It means the coefficient that we'll get will be minus twice the minus square the coefficient of the angle here. Note that. Note. Silly mistake will be minus a all squared is not the same as minus a squared. Please be careful here. These two are not the same. Look how I squared my a. My a is minus a squared, not minus a all squared. No, it is minus a squared. All what it means is that if you differentiate sine ax twice, you will get the coefficient in front with a minus, which will be squared. I guess package, mangithi d squared sine 3x. What is the meaning of d squared? It means differentiate it twice. So d, what is the first derivative? Is what? It's 3 cos 3x. Do it once more. Derivative of that, another 3 comes out. But derivative of cos is what? It's minus. So it's minus 3 times 3. It's 9. Back to the original function, 9 sine 3x. There is the a that I was talking about. Now this a now is what? It's 3 squared. And that 3 squared is that a there. So it simply says that you will go back to the original function once you have differentiated it twice. But the coefficient here will be squared with a minus in front. That is all what it says. But note that minus a all squared is not as the same as minus a squared. So this will always be negative. This will always be negative. That one there will always be positive. Examples. Example 1. We have d squared only if we are taking the second derivative. Sine what? Sine 3x. We've already seen that. It's going to be what? It's going to be, there is a, it's minus 3 squared. 3 squared replaces that d. Plus what? Plus 4. Of what? Of sine 3x. That becomes minus 9 plus 4. Sine what? Sine 3x. And your answer is what? It's minus 5. What? Minus 5 sine 3x. It's minus 5 because there's this 4 there. Otherwise, without that 4, you have seen it's going to be minus 9. Next. Is d squared plus 4d plus 4. The action is on cos 2x. What does it say? Theorem 3. Theorem 3, there is d squared. On d squared only. D squared, it's minus 2 squared plus 4 plus 4. Because d is not squared, we can't apply theorem 3. So we leave it as just 4d. Plus what? Plus 4. On what? On cos what? On cos 2x. That gives us, this is minus 4 plus 4 is just 0. So I'm left with 4d on what? On cos 2x. What is the derivative of cos 2x? Is minus 2 sine 2x with a 4. It's minus 8. What? Sine 2x. Only d squared. Then you must have sine ax or cos ax. On that only. Not on d. Perhaps can be a power of d squared, an even power of d squared. But it starts with d squared. What about this one? What about this one? Third one. 3. 1 over. 1 over what? D plus 2. The action is on cos 3x. In that case there, the rule is quiet. Why is it quiet? Because the d that we have outside is not d squared. It has to be d squared, is it? for us to apply Theorem 3. Find Theorem 3 suits because the bracketed term there is a cos function. But now, cos function, we must have d squared. Or sine function, we must have d squared. So we can create that. We can rationalize the denominator there. Remember how to rationalize the denominator. 1 over. So this is out 1 over d plus 2. We multiply by d
Times
minus
d
2 and divide by
2
d
over
minus
d
2.
minus.
Acting on cos what? On cos 3x. You'll recall this is nothing else but 1, but we have d minus 2 on top. At the bottom now, d and that, that's difference of 2 squares, minus 4, acting on what? On cos what? On cos 3x. Next, it's d minus 2. Then there is d squared now. There is my a. So it's minus 3 squared, be careful, minus 4 on what? On cos 3x. That gives me d minus 2. This becomes minus 9 minus 4. That's minus 13. The action is what is on cos 3x. Apply what is on top. The on that derivative. Derivative of that is going to be what? Minus 3 what? Sine 3x. This times that, it's minus 2 cos 3x. Everything is over what? Minus 13. You can rewrite this in a more mathematical manner. When you simplify it, it simplifies as what? It's what? It's 1 as 1 over 13 into what? Into 3 what? Sine 3x plus what? Plus 2 cos 3x. That's your answer. Are you okay there? Let's look at the next one.
Sure, apho minus man.
Yes.
Baphelele. Oh, ngiyabona. Sengiyabona sir.
Yabon pela nam, yeah, sure. Right. Let's look at the last one. Theorem 3, the last one. It says it's 1 over d plus, we have seen something like that. Let's have what? 20 all over d squared plus 2d minus 3. The action here is a to the power x. Yes, this is a nice one. 3 what? 3 2x, sorry. 3 2x. Now, if I may ask, which theorem am I going to use here? Which theorem am I going to use here?
3. It's theorem 3.
One second.
Theorem 2.
No,
One.
no,
Theorem
no.
2. Theorem 2.
Theorem 2 is the
Theorem 2,
exponential in
sir.
some functions.
Times
Huh?
x times sine square. Theorem 2. Yes.
Theorem 2, is it?
Yes.
Let's use theorem 2. By theorem 2, we say this must be in front. A to the power x, 20 all over. What does theorem 2 say? D is replaced by d of the exponent.
D plus 1.
All squared d into d plus 1 minus 3. What are we left with here? We are left with what? With sine 2x. Next, it's a to the power x. That's 20 all over d squared plus what? Plus 2d plus what? Plus 1 plus 2d plus 2 minus 3, all acting on what? On sine 2x. Please, you have to be careful about these theorems, people. When we solve, we'll be applying these theorems. Right, next we have a to the power x, 20 all over. We add like terms. D squared is all by itself. 4d, 1 plus 2, that becomes 0. The action here is on what? Is on sine what? X. That gives us. D is a common factor from the bottom. We have seen that. That's 20. D is common. Take it out. What are we left with? D plus what? Plus 4. acting on what? On sine what? 2x. 1 over d is known to us, and it. Then we are left with this part. Because we have got a trig function here, we are not going to expand it. We use theorem 3. Theorem 3, but now this has to be squared. This has to be squared. We rationalize. It's e to the power x. It's 20 over d times what? Times d minus 4 over what? Over d squared minus 16. If we rationalize that. Acting on what? Acting on sine 2x. Next is e to the power x. That becomes 20 over d into d minus 4. We substitute. There is what? Minus 2 squared minus 16. This 2 is that 2 there. Acting on what? Acting on sine 2x. Next, it's e to the power x. 20 over d into d minus 4. This becomes minus 4 minus that, that's minus 20. Acting on what? On sine 2x. That becomes minus e x over d into, this is d, into what? Into derivative of that. That is 2 cos 2x minus 4 what? Sine 2x.
Sine
Next.
2x.
But now there is that over d, which means integrate. That gives us minus e x into integral of that. It's what is
It
what?
is sine
Sine
2x.
Integral of that. It's plus
Yes.
what?
It's positive
Cos
2 cos
x.
2x.
Sure. That is theorem 3. Okay, can I move on to the next theorems?
Sir,
Yes.
sorry sir. Yebo sir,
Yes.
ngisacela ukubuza laphana sir. Kunalesa step sir, yabona la kuthiwa khona e to the power x times 20 all times 20 over d squared plus 4d. La ekusakhona ngibuza laphana ukuthi kwaphela sengiyabona ukuthi theorem 3 bekungani ngingavane ngifake laphana se minus 2 lapha ku d squared.
Okay, okay, for minus 2 or Tolabani, minus 4. I think you're going to get the same thing. Then you'll end up with minus 4 plus 4d. Then you take minus.
Yes,
okay, fine. You're not going to get it. Okay, let us do that, but you are not going to get it. Let me write what you are saying. Let me write what you are saying. It's a good question. So you are saying, what is that? It's now it's e to the power x, 1 over what? D. You put out a common factor. Go d plus 4, nah? Then the action is on sine 2x. Angit? No. Not ganje. Uti. E to the power x, 1 over minus 2 squared plus what? Plus 4d. Am I right? Acting on what?
Yes, sir.
Sine 2x. Yes. That becomes e to the power x, 1 over minus 4d, acting on what? On sine 2x. That becomes e to the power x, 1 over, you take d as a common factor the usual way. So it's 4. It's 4. Then you are going to have what? D minus 1 acting on sine 2x. You'll end up with something like this, and it. Now, the next thing that you'll do this, e to the power x, 1 over 4. Then you expand that. Yes?
Sishe. Ngibuza ukuthi ke awukwazini ukurationalize lapha ku masithi minus 4 isho denominator. It's minus 4 plus 4d which you rationalize it.
For x, 1 over 4, rationalize d plus 1 over d minus 1. Usho kanje yangit? Acting on what?
Yeah,
acting on sine what? 2x. Yes, I think this one will be correct. What was going to be wrong is this part. This is going to be wrong. This one, whereby you expand it. You can't expand if the function here is a sine or cos function. That is why you have theorem 2. Otherwise, if you're going to do in this fashion, I think you're going to get the correct answer.
Oh, thank you.
We are just, yes.
Hayi, ngiyakuzwa
Thank you.
kakhulu.
Yeah, right. Let us move on to the next case. However, these theorems, good people, are not without what? Fallacies. In other words, they can fail us. While we can know them as much as we possibly can, but there are instances whereby they fail us. Let us look at the special cases about this theorem here. Special cases. Very important. Special cases. Good people, what we are doing here, our aim is to what? Is to collect all the information using operator D. Once we are done with that, the next thing, we'll be given a differential equation. We'll be asked to solve it using operator D. Right now, we are still gathering that information. Let us look at the special cases. Case 1. If f at x is a constant, if f at x is a constant introduced e to the power 0 of x and what? And theorem 1. It might happen that we are given something like this one. 1 over d plus 2. The action is on 5. That thing is squared. It doesn't say to expand. And then when you expand, how far are you going to go? You don't know, because you'll be guided by function x here. So this 5 here is a constant. This f at x is a constant. Now, this is the case whereby you can't move an inch, but you can move. Because case 1 says, if f at x is a constant, introduce e to the power 0 of x, and then apply theorem 1. Let's do that. So 5 is a constant. So it's 1 over d to the power 2 on what? On 5, e to the power 0x. E to the power 0x is just 1. Then now we can see this is exponential now. Apply theorem 1. It's e to the power 0 of x times 1 over. There is d, which is replaced by the coefficient of the exponent. It's 0 plus what? Plus 2. Then we are left with a 5 there. And this is nothing else. This is 1. So the answer becomes what here? 5 over 2. That's your answer. Otherwise, without that on here, we're just going to be stuck there without going any further. That was example 1, example 2. 1 over d squared plus 4d acting on what? On 8. Again, this is a constant. This is a constant. But before we do anything, there is 1 over d squared and 4d. D is common because 1 over d is known. Then we are left with 4 plus d into what? Into 8. Now focus on that. And this is a constant again. So it's 1 over d, keep it. Introduce what? 8 e to the power 0x over what? Over 4 plus d. Apply theorem 1 by TMH1. Then 1 over d. Then, sorry, it's e to the power 0x. 1 over d. Acting on 8. All over what? 4 plus what? Plus 0 now. That gives us what? E to the power 0x is just 1. So it's 1 over d times 8 over 4 is what? It's 2. Sorry, it's 2. But what is 1 over d? 1 over d means what? Integrate. What is the integral of 2 with respect to x? Is 2x. So the answer is 2x. Are we happy there? So that is a special case, very powerful case. When we solve problem, we'll go through those cases here. Case 1, case 2. I'm not going to stay much because when we solve, we'll go via all the cases. If we apply, now the one who asked me question 1 must understand it now. If we apply theorem 1 and it breaks down, it breaks down. Breaks down means what? It fails. Then we directly apply Theorem 2. Oh, special case. If it happens that we apply Theorem 1 and Theorem 1 fails, then we directly apply Theorem 2. What does Theorem 2 say? D is replaced by D plus or minus A. Let us see. Let us see this one. Very important now. Example 1 all over D squared minus 4 acting on 16 e to the power 2x. The one who asked for Theorem 1, this is Theorem 1. When do we apply Theorem 1? If there is an exponential function. This system is a constant. So the coefficient, the function here is an exponential. These two will replace that. Let's do that. But while doing that, e to the power 2x must come in front. All over. There is d, which is replaced by 2. So it's going to be 2 squared minus what? Minus 4. Then we are left with what? With 16. That is Theorem 1. But when we look at that, that is e to the power 2x. 1 over naught. That is 16. And 1 over naught is undefined. Then we say Theorem 1 fails because we can't continue with that. It's undefined. Then if it fails, while we try to apply it, then we go straight to Theorem 2. Then Theorem 1 fails, versus Tini, we apply what? Theorem 2 direct. Aside big condition that Theorem 2. So it's 1 all over d squared minus 4, 16e to the power 2x. Theorem 1 failed. Then we apply Theorem 2. When we apply Theorem 2, d is replaced by d plus the index, the coefficient of the index. But e to the power 2x must come in front. 2x, 1 all over there is d, which is d plus 2 all squared minus what? Minus 4 on what? On 16. That gives us a to the power 2x, 1 all over d squared plus what? Plus 4d plus 4 minus 4. That gives us what? That gives us 0. So we'll end up with 16 there because I'll get a 4 there and that minus 4 will give us 0. We have seen something like that before. So this becomes, it's a to the power 2x, 1 over d. D is 1 over d is known. Then we're left with what? With d plus 4. The action is on 16. That becomes a to the power 2x. This is what? This is a constant. Theorem 1. Back to case 1. That is 16a to the power 0x all over what? D into what? What? D plus 4. We introduce that. This will come in front. When it comes in front, in any way, it's going to be 1. It's not going to change anything. So it's 1 over d there. Then what here? We'll be left with 4 here. After d has been replaced by that naught there, then we are left with 16. That gives us e to the power 2x, 1 over d. 16 over 4 is what? It's 4. 1 over 4 on d is the integral of 4 is e to the power 2x and what? And 4x as our final answer. All right. Are you still there?
Sorry, sir. Sorry, sir.
Yeah.
Sorry, sir.
Yes.
Oh. And ungibuyelele lapha e 2x 1 over d squared plus 4d times 16 bese uyangehlela ngezansi.
Lana ngithi.
La nje la kuno 1 over d squared minus 4 la.
Yeah.
Ngezansi ukuthi then apply 2 direct.
Okay, sure. In other words,
Yeah.
Theorem 2 says where there is d, you put d plus a. I'm saying about theorem 2. 1 failure maganje. There is d squared. Put use of d plus 2. Now you 2. So it's d plus 2 all squared. Now yeah, minus 4. There is minus 4. Work it out. Square that is going to be d squared. Multiply the product of the first and the second term is 4d. Then plus 4. Plus 4 minus 4. The 4's will cancel. And into 16. Next, there's d squared here. Pull out d as an effect. Then I'm left with d plus 4 into 16. And this is a constant. In case 1, I apply e to the power 0x. Apply e
I think I won.
on this d, not on that d, because 1 over d, it's known. So I can't put 0 here because the theorem will fail in any way. So I put 0 here. Then the answer end up being like that.
Awusazwakali sir.
Asikuzwa Minier.
Kuzwa si.
Hello.
Awuzwakali Minier.
Yes, kuzwa.
Se umuthekile se.
Can you hear me now?
Yebo.
Yes.
Yebo siyazwakala.
All right, thanks. Right. So now theorem 1 here, that in front, then 1 all over. That is theorem 1. Theorem 1d, it's 3 cubed minus 2 times 3 minus 3. The action is on what? 4. That becomes a to the power 3x 1 all over. This is what? This is 9. 9 minus 6, that's minus 3, that's 3. 3 minus 3, that's 0. Actually or not, on 4. Then 1 fades again. 0, 1 fade. We can't continue. Fade. We apply theorem 2. Therefore, by TMH2, we have a to the power 3x 1 all over. There is d, which is d plus 3 now. All squared. Minus 2, d plus 3, minus 2. And then you're left with a 4 here. Okay? That becomes a to the power 3x times 1 all over d squared plus 1 plus 6d plus 9 minus 2d minus 6 minus 2. Yes?
U2 minus 2 suphume ngoba ngibona minus 3 lapha Minier.
2 oh, sorry. This is minus 3, sorry.
Oh, ngiyabonga Minier.
Right, thank you. Right, we add e to the power 3x 1 all over d squared. We add to that and that. That is going to be what? To be 4d. That and that and that. That is out. That is on 4. I think we've seen that again.
That gives out as a common fact.
E to the power 3x, almost the same. 1 over d into what? 1 over d plus 4. The action is on 4 here. Bese result nje by e to the power 0x here, theorem case 1. But not on 1 over d. That gives us e to the power 3x, 1 over d will be left with 1 over 4 and 4 there by case 1. that give us e to the power 3x, 1 over d. Everything that we are going to remain with is just 1. What is the integral of 1 with respect to x? Is x. So it's e to the power 3x times what? X, or x e to the power 3x is your final answer. Good people, thank you. I'll see you tomorrow at 7. I think the one who had a problem with theorem 1 is now able to solve, to go through, understand it. Okay?
Oh, okay. We have a time to sing again very quickly.
Angizoma?
We have a time to sing very quickly.
Tomorrow at work, I'll go to the IT department so that they retrieve all the recordings for you. I will send an email, a WhatsApp to one of you. Then you will distribute to the rest.
Okay, thank you.
Okay, tomorrow again. Yes.
Tekubuza uma ukuthi na bafela bonke utheorem 1, theorem 2, theorem 3 bafela bonke senze njani?
Hayi angasikasi naleyo case.
Wrong.
That will be more advanced.
Yeah.
Good people, we are approaching our test. Our test won't be next week. It will be that other week. I will give you the date specifically. Okay.
Sir,